2? 2 is good. All right, so suppose f of x and gx, there are two functions which satisfies the following. We know that f of 2 is 3, f prime of 2 is negative 2, g of 2 is 2, and g prime of 2 is negative 1. Now, under this assumption, A, figure out the derivative of f g of x at x equal to 2. Well, it's a nested function, so you just use the chain rule. Differentiate the outside, leave the inside as it is, pull the inside out, and differentiate that. And we have to plug in x equal to 2 afterwards. This bar means only after you've completed the derivative, you're going to plug in 2. Now, we can't go on anymore. We don't know what f prime is, we don't know what g prime is, so I guess now you don't have any choice but to plug this in. Okay? So let's plug this in. F prime g of 2, g prime of 2. Then we go back and see if there's anything that we can use from here. What can we use? G of 2 is what? Is 2, so I can replace that by 2. What's g prime of 2? It's negative 1. So g prime of 2 became negative 1, g of 2 became f prime of, g of 2 became 2. That's what I'm getting. So maybe I should circle it. And circle it. Okay, so this became that. Okay. Now what is f prime of 2? It's negative 2. So it must be 2. Second question is also done similarly. Again, this question. In this case, the outside function is the cube function. It's like x to the third power. What do you get if you differentiate x to the third power? 3x to the second power. But what I'm thinking of as x is really f of x, so that's what you get. Now, what does the chain rule say? The inside function should be pulled out and differentiated. And then I have to plug in 2. Therefore, this is at 3 times f of 2 squared times f prime of 2. And then we can use the numbers given up there. That's f of 2 is 3, f prime of 2 is negative 2. 3 squared is 9, 9 times 3 is 27, times negative 2 is negative 54.